In this video I'm going to express cos n theta or sin n theta in terms of cos theta or sin theta. Just to say this in all the past exam papers, this rarely if ever comes up, but here it is anyway. So first of all I'm going to express 2 theta in terms of cos theta. Right, the first thing I do here, right, and I always stick to this method, is if I'm asked about cos something theta, right, in this case cos 2 theta, I will write out the cos 2 theta, but I'll also write in the sine equivalent. Likewise, if I was asked about sine some number theta, I would write in the cos equivalent. Now, if we look at this, based on de Moivre's theorem, I can say that's cos theta plus I sine theta squared. Okay, if you know de Moivre's theorem, you'll know exactly what I'm talking about there. So I can say that that is cos theta plus I sine theta multiplied by cos theta plus I sine theta. So I'll multiply them out. So it's this by this and this by this first, which is so the first one is cos theta by cos theta is cos squared theta, plus cos theta by I sine theta is cos theta I sine theta, and then this by this is also cos theta I sine theta, and the last bit is I sine theta by I sine theta is I squared sine squared theta. So tidying that up, I have cos squared theta, okay, and I have cos squared theta plus 2 cos theta I sine theta plus I squared sine squared theta, which will give me cos theta plus 2 cos theta I sine theta minus sine squared theta. Now I'm just going to rewrite this again. We have cos 2 theta plus I sine 2 theta equals cos squared theta plus 2 cos theta I sine theta minus sine squared theta. Now, what was I asked about? I was asked about the cos element, which is this bit. Now we ask ourselves, is that real or imaginary? There's an I here, so the sine is imaginary, the cos is real. So we take the real bits, and we can say cos 2 theta, we take the real bits over here, so which is anything without an I, so it's that and that, equals cos squared theta minus sine squared theta. Okay. Now notice here we have cos 2 theta equals cos squared theta minus sine squared theta. But if we look, we have to have it in terms of cos thetas, not sine thetas. So I need to try change this sine squared theta to something with cos in it. So I need to get rid of the sine. To do that, I will take something out of the log books. Okay, here it is. Sine squared theta plus cos squared theta equals 1. For any of these questions, this here is important. Why? Because it allows us to write anything with sine in it or cos in it as something without sine or without cos in it. For example, I want to see what minus sine squared theta is. Alright, so I'm going to get everything to one side except the sine. So watch. So using this here, I'll say sine squared theta plus cos squared theta equals 1. I can then say sine squared theta equals 1 minus cos squared theta. But remember, this is a minus sign, so I'll change the signs the whole way across. So minus sine squared theta equals minus 1 plus cos squared theta. And what would be neater is if I said minus sine squared theta equals cos squared theta minus 1. Okay, just to flip, just to not start with a minus. Okay, so now I know that minus sine squared theta is cos squared theta minus 1. So I'm going to substitute in minus sine squared theta with that. So here we go, we'll write it out again. Cos 2 theta equals cos squared theta, which I get from here. And instead of writing in the minus sine squared theta, I will write plus cos squared theta minus 1. Notice I have two cos squared thetas now. So I can say 2 cos squared theta minus 1. And there, I've done that. Okay, I've written cos 2 theta in terms of cos theta. And there we go. Just following on from this, if they asked, instead of cos squared 2 theta, if they said sine 2 theta as sine theta, well, I would do the exact same, except when I got to this stage here, I wouldn't be equating the real parts, I would be taking the sine parts, okay, the bits with the I, and then I'd be doing the exact same thing again, but this time using the imaginary parts equaling each other. Okay, thanks guys.